Hey everybody, welcome back. Again, we just saw from Andrew Caldwell talking to us about Aqua for Amazon Redshift, some exciting work, full stack on accelerating Amazon Redshift queries. Joining us now is Satish Sathya talking to us a little bit about the super data type for Amazon Redshift. Satish, I don't want to jump in front. I know you're the expert here. First of all, thank you for joining us.
Thank you for having me here.
So, we've covered. Oh, go ahead.
Sorry, Nick. We are just destructive interference today. I'll take this one. Satish, maybe you can give us the elevator pitch here. What is the super data type and why is it so cool?
Super data type simplifies the ingesting JSON documents or semi-structured data into Redshift, which was not possible before. Before the introduction of super, semi-structured data needs to be pre-processed before ingesting into Redshift. So now with the advent of super, that eliminates that data processing pipeline.
So if I'm hearing this correctly, it had to be processed before. So let's say I wanted to perform, a lot of web data will be returned in something like JSON format. What I'm hearing is if I want to use Redshift to power basically my processing and then transforming back on the way out for a web app, I would have to have some ETL or like pre-processing infrastructure and glue code in front of Redshift. And then if I wanted to also return that in something like JSON, I would also need to potentially have post-processing done. So we're talking like an entire proxy service or multiple services just to be able to perform analytic or perform the processing with Redshift on semi-structured data. Does that sound right?
Correct. I can elaborate more on that. So before the introduction of super, right, semi-structured data like weblogs, industrial IoT data needs to be pre-processed outside Redshift using some other tools like Glue or Athena to flatten the nested structures and apply a relational model to the data before ingesting it into Redshift. So you need to have a pipeline to do this. And because the semi-structured data can be flexible and potentially evolve with the addition of more columns or deleting columns or changing the data types, the pipeline needs to be fixed whenever that change happens. This delays the time to get insight from the data for the end user to make quicker business decisions. But today with Super, the ETL pipeline is like simplified into simple SQL commands.
Awesome. So I'm assuming.
So are you saying?
Oh, go ahead.
Just to kind of elaborate on that, you said that these two use cases you brought up, weblog use cases and IoT use cases. Did I hear that correctly?
Correct. Any semi-structured data that these devices, IoT devices or weblogs that they generate, which are hierarchical or nested in structure.
Right. And so is it the case that once you start to use the super data type that you can reduce the amount of ETL that you do, or is it completely gone? How does that work?
You can, so Redshift Super allows native support of semi-structured data, right? So with Super, customers can store the raw JSON or other semi-structured data without the need to predefine a schema for your data. Schema evolution is natively handled as super data type is flexible, and I can accept anything or everything at it. So the same raw structure is maintained inside super. So basically we eliminate the need for ETL.
Okay, so what happens if I could see how that would work for two, let's say, HTTP request headers that are both JSON blobs, and they have a lot of overlapping fields, but some fields might be optional, or they might be one or two fields that differ between these two documents. Is that a good example?
Yes. Like I said, the schema evolution is handled natively, so you don't need to worry about the changes in data types or the changes in the number of columns. So once ingested, nested structures can be directly accessed using the dot or the bracket notation, and can also be flattened using simple SQL. Also, most of the data operations like joins or aggregations or any mathematical functions, for example, can be applied on Super, just like you do it on a scalar data type. Super has this dynamic typing capability by which you don't need to explicitly cast the columns to a specific data type. Super handles this inherently or implicitly. So what that means is if a column data type started as an integer and later changed into a varchar, and then later evolved into an array because due to business decisions, Super natively handles these different types present in a single column without the user needing to explicitly cast that into appropriate types. This enables faster insights into the data and immediately ready for query as soon as the data is ingested.
Yeah, I think that's a super interesting point, right? The ability to now take semi-structured data, which may take a number of forms, seems like additional freedom, but then could also have some additional constraints if you had to cast the type, or if you didn't, it would break. But what I'm hearing here is that, again, sort of leaning into the fact that we have heard how customers, what their data looks like sort of in the wild, and are sort of meeting them with automatically assuming what that is or changing as the data type changes over time. It makes these interfaces a little bit less brittle, right? You don't have to have some statically typed preprocessor that expects type A, converts it to type B, and then hopefully that aligns with schema on destination table C. It really feels like we're cutting out that intermediary and helps the data source and the processing engine in Redshift here interface more effectively directly.
Absolutely right. So an interesting thing is this happens at runtime. So the dynamic typing kicks in at runtime, analyzes your different data types present in a column, and answers your query based on that.
Yeah, I'm really interested to see how this works in practice, because I've already got a couple of edge cases in my mind, like what happens if you throw out two JSON documents with no overlapping fields. Do we by any chance have a demo that you could show us?
Yes, I put together a very simple demo I can show you. Let me share my screen.
Yeah, I'm excited to see this because I'm used to working with Redshift and putting my SQL in there, but being able to now have like a JSON object explorer or seeing this in action is going to be exciting to me.
Can you guys see my screen?
Yeah, I see what looks to be some example, like a JSON object. Is that right?
Yes. It's a simple JSON object I put together to show this super demo. It's about this JSON document stores details about books and the author and the editor, the ISBN information. There are two JSON records in this document. If you see, the first title is Outer on the Dragon, and the second one is The Solitary Boy. The interesting thing is, while ISBN is a scalar data type, but the author is a structure because it has like a last name and first name built into the author. Similarly, editor is a struct. It's a last name and first name. And the category, if you say with the bracket notation, it's an array. Interesting, if you like, I talked about the dynamic typing, right? So in this use case, which I put together, the first record of category as a varchar items in the category, which is fiction and fantasy. But if you look at the second record, the same category has integers in it, right? So these are different data types under the same column, right? So let's go into the actual demo to see how this is processed. So I'm going to drop the table if it's already exists. But if you see here, I'm going to create a simple table called books with a single column called super. This is very useful when you don't know the structure ahead of the incoming JSON document. Although I've shown you the JSON document here, sometimes industrial IoT or any other use case, right? Sometimes you don't know the number of columns in it. In that case, you want to do some exploratory analysis. In this case, you just want to create a single column which will ingest the whole document into this B, which is a super type. So I'm going to go ahead and create this table here. The table is created. I have uploaded this same file that I showed you into S3, and I'm going to use the traditional copy statement to load this into this books table. The only change I'm doing here, which is new for Super, is you support an option called no shred along with JSON, which tells the copy statement to load the data as is without shredding it. I'm running it. The copy is done. So,
sorry, what does without shredding mean? Can you elaborate?
Without shredding means I want to just ingest the whole JSON document without loading it as individual columns like ISBN or author. So everything goes into this column called B, which I just created. So So I'm going to use the dot notation, which is usually done for accessing the elements of a structure, which in this case are structures are author and editor. So I'm going to access them using the dot notation here. So select ISBN, author name. So use the dot notation here, author name dot last name, and the editor dot last name. So even though last name is present, but it's uniquely defined by the structure name here. So I'm going to run this query. So I get the last name for both the author and the editor by using the dot notation. This is to access the structure. So we saw.
One second. But before you go forward, because there's additional exciting stuff I know you're going to talk to. In those 3 queries I think we've performed thus far, we have created a table that's natively, like with a column of super data type. That's brand new, right? Previously, it only had to, there were other data types that were less flexible, I guess you could say. We've copied the data from a source, which was essentially just that JSON that we expect to receive from web apps pretty commonly. And in your third command there, we were able to essentially perform a query against that data in the way that we would traditionally do with object notation, like in 3 steps, in 3 queries, right? Now substitute your data source and your JSON object there, substitute your S3 bucket name, and you're off the races with querying using Redshift and SQL your semi-structured data. Like in 3 lines of code, or 3 queries, I guess you could say. But very easy to reason about how to do this. And I know you're going to show us some more exciting stuff, but just thinking about the world of having to have this pre-processing done, where you have this like implicit or like this like loosely coupled contract of having middleware that tries to guess what sort of data type it's going to receive and then output and then hope that your database accepts it. Just seeing this all in such a simple sort of format is really enlightening to me.
Yes, a lot of customers are excited about this. A lot of customers. Let's move on to the next one. So previously I showed how to access a structure, right? So remember, everything is under this column called B, which is a super type. So now if I want to access this array called category, and also the 0th element or the first index of an array called category, so I just need to use the bracket notation here. So this just accesses the first element in that array called category. So I use the bracket notation to access the arrays, and I use the dot notation to access the structs. Also, if you want to flatten your array into relational columns, right? So flatten means like you want to access every element in the array, right? So if you want to flatten it or unnest it, that's the term used. So you just need to create a table alias. So in this case, I'm selecting from books, and I gave an alias called BO. And to access the category, I'm creating a new alias out of it, which is called C. So basically, it's bo.b and category. So I create a new alias called C, which will be used to iterate the array called category. So let's run this query. Again, this query is to unnest or flatten the array. So I've unnested or flattened the array here. So if you look at the original category array here, I have 4 elements: fiction, fantasy, 1, and 2. So I kind of unnested it using an alias by providing an alias to the array name. Oh, so I also talked about the dynamic typing, right? So I intentionally added different data types for the category. So in the first query I'm doing here, it's the same query as above. I'm using alias C to iterate over the category array, and I'm looking for just the fiction types, the fiction categories. So I'm running this query here. So I just get this this output, which is a fiction category. So in the second query, I'm running the same query, but this time I'm using an integer as a predicate. In a traditional database, the way the data types are strictly typed, this query will fail, or the other way around. If you type a varchar, it will fail because it will complain it's a different data type. Now, if I run this, it's going to give me the results. So it's not going to complain. So this is the power of dynamic typing that happens at runtime. Let's move on to the next section, right? So the first section talks about how to ingest the data if you don't know the number of columns or the types within the JSON document. What if you know some of the columns ahead, and some of the columns are nested. So we know the author and the editor and the category are nested, while ISBN and title are simple scalar columns, varchar columns in this case. So to make this faster, I'm going to create another table. In this table, I'm going to create ISBN as varchar because I know it's a varchar column, and the author as super, and the editor as super, and the title as varchar, and the category as super, because I know these three guys are nested columns while the others are scalar columns. So I'm going to create this table. Let's check the output. Yeah, the table is created, and I'm going to run the copy command. It's the same copy command. The only difference is I'm going to provide auto, which means please shred the JSON document according to the column name present in the JSON document. So I'm going to run this copy command. And the copy command is done. So I'm going to run the same query that we saw before, just a little modified, and it should work just as it is. So this is the most preferred way of loading a JSON document if you already know the JSON content well ahead. So I'm going to talk a little bit about the materials view. Go ahead. You have a question?
Yeah, I mean, more of just making sure I'm understanding this. Like, to me, what this seems like, I know we live in a world where it feels like folks typically have to choose between relational data or unrelational data, or maybe they have it in one that they need to transform into another. And what I'm sort of seeing here is you are not forced into a choice. You can now bring semi-structured data here into Redshift and not need to write all of this custom code to basically unnest it or to unravel it or shred it as you're describing, and just continue to use the interface that folks that are processing that data usually use, like SQL, with some minor modifications for how they're accessing object property types, and it just sort of works in the interface that they're already using.
That is true. That is true. The second case is mostly useful if you know the schema. Like I said, if I know the schema well ahead, and also the important thing is you want to take advantage of Redshift's columnar architecture as well, because Super stores the raw structure as it is. It is it's currently stored in a row format. So if you want query speed up, then we recommend, and if you know the content already, we recommend shredding the JSON document into appropriate columns for query speed up. That's one of the reasons I mentioned this is one of the recommended ways to do it if you know the structure already.
So Satish, speaking of shredding the data here, as you're going through this example, I'm thinking back to cases where I've written snippets of ETL code, and in a case like this, something I might do is to take the editor or the author, let's say, right, and I might create an author table and insert all the authors there, and then replace that with a foreign key in the books table. Is that something that Redshift, or how would we handle a case like that, or is that even something that maybe it's not the direction that we should be heading in?
In a traditional database, that's the way you do it. You have separate tables for all the dimensions, and then you perform joins when you want to access the elements from different tables of this nature. But with nested data or JSON semi-structured data, the reason they are nested together is to avoid joins the way it's designed, because you want to place the dimensions closer to the fact. That's how this nested data types were evolved. And so Redshift wants to way to ingest this type of data natively, because we've seen more customers looking for ways to load this JSON data as it is.
I see. So
it provides a way for that.
So it could be done, but in this case, some kind of the benefits of having the super data type is the fact that you can take advantage of the inline nesting with the document itself.
Correct.
Got it. Thanks.
No problem. Yeah. So also, like I mentioned, right? So if you frequently access these super columns, then our recommendation for query speed up is to create a materialized view on top of it. By creating a materialized view, we are truly taking advantage of the columnar nature of Redshift. So in this case, I'm creating a materialized view, assuming this is the query that I run and frequently access the super types here, like I'm highlighting here. So we recommend creating a materialized view on top of it.
We
just creating a materials view on top of it.
Go ahead.
Sure. And once the materials view is created, which is in columnar format, Redshift's native columnar format, then you can directly query them. So this is again for query speed up. Once you ingested the data and you know what you're looking for and the type of queries that you want to perform on nested columns, we recommend creating a materials view. With the automatic refresh on materials view, any incremental data is automatically recomputed for you and ready to be queried.
Yeah, this is this again. I feel like a broken record, but it really starts to just continue to feel like the best of both worlds, whereby customers can not have much of an understanding of what their data is going to look like before ingesting it into a super data type column. But additionally, if they do have an understanding of their data, some of the workloads they're going to use, they have the levers with materialized views to be able to still leverage that flexible JSON semi-structured format, but speed up their queries with, again, materialized views. So again, sort of improvements that grow with you, but offer you the flexibility to get off the ground a little bit quicker.
Yes.
We actually had one question from. Oh, you can go ahead.
Mm-hmm.
We had one question from LinkedIn wondering how does this compare to something like an ODM? I think that's like an object document mapping. Does the customer have to think about that? Does that come into play at all here? Can you talk to that at all?
Can you repeat the question? Is that ODM you mentioned?
Yeah, so a customer was interested in knowing how the super data type compares to something like an ODM. Or is it different than that?
I'm not very familiar with ODM. I'm not very familiar with ODM, but super data type is like the superset of all the data types available, including the scalar types and the nested types. So you can throw anything and everything at it, and you should be able to query using simple SQL commands.
Sounds good. Yeah, thank you.
I can find out more about ODM, and if required, I can provide more details if do a compare and contrast and for ODM as well.
Yeah, we'll follow up in chat later on with that question, but thank you. Yeah, okay. You can keep going.
Oh, that brings the end of the demo. So I wanted to keep it very simple for the audience.
Awesome. Yeah, I apologize. I feel like I've sort of rehashed and summarized along the way because I needed to make sure that I could understand all of this. But again, I think we saw sort of 3 steps there. First of which is ingesting the semi-structured data with, if you scroll up to the top, we'll be able to see that in just those first few lines. Really, the magic is in that now the Redshift service supports this super data type. You define that as the data type for a given column, and then you copy and load in data as if it were a known type. And that sort of is twofold benefit. Again, you can just process JSON data as is, not requiring pre-processing, but then you're performing the selects and the queries against that object with a really familiar sort of object relational syntax there directly from SQL. Again, just folks using Redshift are using SQL, and now you've brought this functionality and very easy to use sort of syntax directly to them. So very, very exciting.
Thank you.
Is this feature generally available?
Yes, it's generally available as of April last month. It was started as a preview feature at last year's event, and it's GA since April.
Awesome! Congratulations! A lot of really great stuff coming out of the Redshift team just in the span of a month. That's great to see.
I have one question, and maybe it's a little silly. JSON can be nested in any number of levels, I suppose, right? Depending on your needs. Is there a max level of nesting that is supported here that I should worry about potentially running into?
Yes, the max level that we support as of today is 512 nesting, up to 512 nesting. But that's like too much, actually. It's very rare case you'll find a document like that, but that's what we support today.
I was just about to ask, yeah, have you seen a 512 level deep JSON document?
No, that's very rare scenario.
I think I'm gonna need 3 ultra-wide monitors side by side to like actually get to any of the keys or values after 512 levels of nesting. I feel like there are other scaling concerns with how you even reason about that data before you start to wonder whether you can store it. I think there's some other questions someone should probably be asking themselves if they have something of that magnitude of nesting.
That's when super really helps. That's when super really helps. You don't need to look at the 512 nesting. You just need to use create a super column and just ingest into it, and then you can SQL to explore it.
And just remember to type 512 dots. So speaking of these use cases, you guys launched last month. You were in preview mode since reInvent. What have customers done with the super data type since then? Can you share any stories here?
Yes, I have a couple of customer quotes. I can read that out for you. The top customers, no, I wouldn't say top customers. Some of the customers who tried this out so far is Yelp, Sony, and a customer called LiveSense. So I'm just going to read up the code that we got from Yelp. So we are excited to see the Amazon Redshift super data type general availability. Native JSON data often appears in our infrastructure edge environment. To avoid intensive data engineering to flatten their schema, we may store the JSON document as varchar. That only allows us to use JSON extract functions to access the stored JSON document for analytics. Super is a game changer for us to use a particle style SQL accessor to query semi-structured data seamlessly with the much better developer experience and sometimes even better access speed. That's one of the quotes we got.
That's awesome. And I know you mentioned something in there, Particle. It's an open source query language that I know AWS has supported. I don't know if it's from AWS. I'm drawing a little bit of a blank there, but again, I think just speaking to the fact that data exists in this format already and now extend the super data type just helps to meet that data where it is. And nobody was happy with having to perform that ETL before. It was undifferentiated heavy lifting for everybody. And it seems like this is really going to accelerate and give confidence for how they're processing this data using Redshift.
You had to say it, Nick.
The running joke here is that we can't get through a single show where Nick doesn't say the term undifferentiated heavy lifting. But hey, if service teams like you are releasing features that keep removing that boring and non-business value driving sort of work, I'm happy to keep talking about it. So you all keep me honest, and Rob just has to put up with hearing me say it, and the audience at least. But they haven't yelled at me too much.
And Twitch needs to turn this into a drinking game.
Maybe it's a channel points reward that we have to add, but I don't want to keep you along with our hijinks here. I just want to say thank you. This was super concise, and again, seemed like a really hairy problem before, but the super data type really just makes this easy, meets customers where they are, meets customers' data where they are. Most importantly, data has gravity. It's a term Andrew didn't say, but I'll say it here on this segment. And I think, again, this opens up a lot in terms of the flexibility, because customers are working with semi-structured data in a number of different databases that may not have been as easy. Again, we saw the Yelp use case, having to just ingest it as a varchar, and there's a lot of downsides to that. So now having that as just a single column type, dynamic typing, auto unnesting, chef's kiss. I love to see it. Rob, anything else in closing here? I think we really touched on everything.
Yeah, short and sweet. Love it.